All right, let's keep rolling. And we'll start with number 51. It's important to remember that when we are solving absolute value equations, there are going to be two solutions. The first solution is found by writing the equation just like it's seen, but without the absolute value bars. The second solution will be found by writing the equation just as it's seen on the left side, but changing the right side, the number, to a negative. So 1 is 3t minus 3 equals positive 6. 1 is 3t minus 3 equals negative 6. Now the reason for this is it's true that this will equal 6 if the inside is equal to positive 6 or negative 6, because the absolute value bars will change any negative to a positive, and it'll keep it positive the same. So we add 3 to both sides, giving us 3t equals 9. Then we divide both sides by 3. And for this first set, we get t equals 3. By the way, isn't this a really cool pin? Just got recently from my mom. Yes, I'm 39. My mom still gives me stuff. And this one's cool. Anyway, I'll go ahead and mark this one over here. T equals 3. Fill it in. Now we'll solve this one. Add 3 to both sides. Gives us 3t equals negative 3. Then we'll divide both sides by 3. We get t equals negative 1. And our mission is complete for that problem. Okay. 52 we'll do in a very similar way. That's our first equation, just as it is, but without the absolute value bars. Our second equation, we make the 1, this one over here, negative. So I'll subtract 1 from both sides, give me 2a equals 0. Divide both sides by 2. I get a equals 0 is my first answer. I'll subtract 1 from both sides, get 2a equals negative 2. Sorry, I went a little fast there. So I subtract 1 from both sides, get negative 2. Then I divide both sides by 2 to get that a is equal to negative 1. So those answers are very close together. Okay. 53, we're doing the same thing, but in reverse. In 51 and 52, they gave us the equations, and we found the solutions. In 53, they're giving us the solutions, and we need to find the equation. Now, the general pathway for this is you do the absolute value of x minus the midpoint. That's whatever number is exactly in the middle or in the center between the two answers, is equal to the distance from the midpoint to a solution or an answer. So on this one, if you look, what's exactly in the middle between negative 3 and 5 is negative 1. No, sorry, I don't know why I said negative. That's a positive 1, just for everyone's information. You can also do the counting, and you can say, okay, I'll come 1 in, come another in, come another in, and there I am, right there at 1. So I'll do the absolute value of x minus 1 is equal to, and then you can do the distance from the midpoint to either of them. Just make sure you make it a positive distance. So I always just go positive direction. From 1 to 5, that's a distance of 4. So that would be the answer. Okay, 54, we're trying to see if these fractions are equal. To figure that out, you can just reduce each one, see if you get the same result. 12 and 10 are both divisible by 2. 26 and 20 are also both divisible by 2. And it proves these are not equal. I should actually have a comma right there. I keep making that mistake. But we're testing to see if they're equal. These two are not, because when we reduce them, we don't get the same result. So we'd say no. And I want to see this work shown on this, because otherwise I know it's just a 50-50 shot of you guessing. So show that you've reduced it so I know you've actually done the work. On 55, 2 over fifths is already fully reduced. 14 and 35 are both divisible by 7. 14 divided by 7 is 2. 35 divided by 7 is 5. So yeah, these are equals. We would say yes, they are equivalent ratios. Okay, on 56 through 59, we'll be doing the cross multiplying and dividing. So for the most part, there's an exception on this one, but for the most part, it's just cross multiply, then divide. So negative 4 times a equals 8 times 5, which is 40. Then I'll divide both sides by negative 4. And anytime you divide a positive by a negative, the result is negative. So we'll get a equals negative 10. So we'll follow the same process on 57. 5 times x is 5x. 4 times 15 is 60. Divide both sides by 5. Get x equals 12. 58, t times 42 equals 6 times 7, which is also 42. So we get t is equal to 1. Okay, 59, due to the binomial, this thing has two terms right here. We will have a little more work to do. I think just one more step. But remember, when you multiply by the binomial, you've got to put parentheses around it, because 10 is multiplied by the whole thing, not just the x, not just the 2, but both of them. The negative 6 times 5 is negative 30. You can certainly distribute if you want to. There's nothing at all wrong with that. But it is quicker, I think, to just divide both sides by 10. Giving us x minus 2 equals negative 3. Because a negative divided by a positive is a negative. And we add 2 to both sides. And we get x equals negative 1. Percent change. Okay, the way I generally set it is it's always the amount of change over the original. Now another way you can think of it is it's the new value minus the original over the original. Now that's the same thing as what I said when I was teaching it to you. It's just that this is showing you how to find the amount of change. So it's change over original. Okay, so new minus original, that's gone down 15, so I'm going to put negative 15 here. And I put that over the original amount, which is 25. And then I actually divide these. I mean, you can reduce it if you want to, but this is one I actually need you to divide it and tell me what the decimal is. Because this one would be negative 0.6. And remember, to change it to a percent, you move the decimal place over 2 spots. So you'd say it's a negative 60%. Now that negative is what tells us it's a decrease. If you'd rather say a decrease of 60%, that's fine too. I'd accept that completely. Just make sure you don't combine both a negative and a decrease, because that gets complicated. But you can either say negative 60% change or a decrease of 60%. On 61, the change is that it goes up 60. You can find that by saying 240 minus 180. So the change is 60. And we put that over the original, which is 180. So that ends up 0.3 repeating. And to change that to a percent, we move the decimal place over twice. So we'll just say 33.3% is the change. Now since it's positive, that shows it's an increase, or you could write increase of 33.3%. Okay, 62 and 63 are called literal equations, or solving literal equations. And I did these because these show up often on standardized tests like the SAT and the PSAT and the ACT, all those fun letters. Hey, and look, these are letters too. How about that? So on 62, our goal is to get x by itself. So I want you to think just like we did when we were solving equations. We've got 4 letters going on here. X is the one we want to get by itself. A and B are both very close to it. C is farther away. So the first thing I'm going to move is the C. It's a negative C, so I'm going to add C to both sides to move it. Now, if you want to do it in just one more step, you can multiply the top and the bottom, multiply by b over a. Because anytime you want to get rid of a fraction, you can multiply by its reciprocal. That's the same thing as dividing by it. So the same thing as dividing both sides by a over b is multiplying both sides by its reciprocal, b over a. Because you see then the a's cancel and the b's cancel. And we'll treat this just as c over 1. So we get x equals cb, or bc, I don't care what order you write it in, over a. Now, just to show you how you can do it in 2 steps if you want to instead, here's where we were after we added the c to both sides. Because I know it throws some people off trying to use this reciprocal thing. You can do it in 2 steps. You can say, I need to get rid of the b, and it's being divided right now. We're dividing by b, so I'll multiply both sides by b. That cancels out the b. Then to get rid of the a, which is multiplied by the x, when you divide by a. So you see we get the same answer either way. So it's okay to use it in 2 steps, get rid of a over b, or 1 step. 63, we want to get h by itself. 1/2 and b are both real close to it. They both need to be moved, so it doesn't really matter which order you do it in. So I'll just start by dividing both sides by b. So I get a over b equals 1/2 h. And you can say we'll divide both sides by 1/2. That's true, that works. But dividing both sides by 1/2 is the same as multiplying both sides by 2. Because 2 times 1/2 is 1, so that just cancels out. We get 2a over b is equal to h. Okay, 64 and 65. Determine whether each equation is a linear equation. If so, write the equation in standard form. 64 is not linear because we have 2 variables being multiplied together. Other things that make it a no, just as a reminder, are if we have exponents of any kind, or if we end up with a variable in the denominator. So these are just other things that would make you answer no, they're not linear. Now 65 is linear, so we need to put it in standard form. Well, standard form, just as a reminder, is ax plus by equals c. So they've already got the ax in the spot it's supposed to be, by is in the right spot, but we need all the constants to be over here on the right side. So there's just one step we need to do, and that's subtract 7 from both sides. So 3 minus 7 is negative 4. Okay, on 66 and 67, we've learned at least 3 different ways we can graph equations. One is to find the x and the y-intercept. One is to use a table. One, especially when it's in the form you have like 67, is you can graph the y-intercept, since this is in slope-intercept form, and then use the slope to find the second point. I'm not going to be picky about which one you use. You can pick any of the 3 methods. I'm just going to use the ones I think are most convenient with the graph or the equations in the form they're already in. So this one, I think it's easiest to do the 2 intercepts first. So the x-intercept is found when you plug in 0 for y. So I do x minus 2 times 0 equals 4. 2 times 0 is 0, so we just get x equals 4. So I put a point right here on the x-axis at 4. Then for the y-intercept, I do the opposite. I plug in 0 for x. Okay, well that 0 just disappears. Then we'll divide both sides by negative 2. So we get that the y-intercept, and again, that's where it hits the y-axis, is at negative 2. So now that I have those 2 points, I can draw a line through them, and I have my graph. 67, it'd be pretty easy to use the table. It's also pretty easy to do the slope-intercept method, so I'm just going to use that because we can look right here and know that's the y-intercept, because this is the slope-intercept form. So that number, the positive 1, tells you the y-intercept, meaning that it hits the y-axis at 1. And the slope is negative 2 over 3, meaning from this point, we should go down 2 because of the negative 2, and then over 3 because of the 3 on the bottom. Now, some people say, well, where is the negative? You can put it in either spot. I treated it like the negative was on top, but I want to show you that it really does work either way. Let's say this was 2 over negative 3. So if I started this point and went up 2, the negative 3 on the bottom tells me to go left 3. As you can see, that's right where my arrow was going through. So that would also give me a point on the line. So you can go either direction. I find it easiest to just put it on top, keeps things simpler, but you can do it either way. Okay, 68, we're finding the x and y intercept. So again, to find the x-intercept, plug in 0 for y. So x minus 2 times 0 equals 9. 2 times 0 is 0, so we just get x equals 9. For the y-intercept, we plug in 0 for x. So that 0 disappears. We divide both sides by negative 2. And you can say negative 9/2, that's fine. We can say negative 4.5. And on these questions, it's completely fine to just leave the answers as numbers like this. But just so you're clear when you're graphing, this means we have the ordered pair 9, 0, because we found x was 9 when we plugged in 0 for y. And this would be the point 0, negative 4.5, because when we plugged in 0 for x, the result was negative 4.5. Same process over here on 69. To find the x-intercept, plug in 0 for y. I'm going to add 4x to both sides. Divide both sides by 4. And we get that the x-intercept is 2. Now for the y-intercept, do the opposite. We plug in 0 for x. Negative 4 times 0 is 0, so we end up with just y equals 8. Which also is just that number right there, because this is in the slope-intercept form, so this number does tell us the y-intercept. Okay, find the 0 for each function. The 0 of the function is the x value that makes either y or f of x. They're the same thing. F of x and y mean the same thing. The 0 of the function is the value of x that makes y or f of x equal 0. So to find it, we just plug in 0 for y. I'll add 14 to both sides. Then divide both sides by 2. So this has a 0 at x equals 7. And if you don't remember, the 0 of a function is the same thing as its x-intercept. So you notice the process is the same. To find the x-intercept, we plug in 0 for y. To find the 0 of a function, we plug in 0 for y. And f of x and y are the same thing. There's no difference between the two. So whether they say y or f of x doesn't matter. We still plug in 0 for that. So on this one, I'll subtract 6 from both sides and give me negative 6 equals 2/3 x. And like I did on a previous problem, you could do this in one step by multiplying both sides by 3/2, because that's the reciprocal of 2/3. But I'm going to do this in 2 steps. I'll multiply both sides by 3 first. So the 3's cancel. 3 times negative 6 is negative 18. And we get 2x on that side. Then divide both sides by 2. So we get the 0 of the function is negative 9. Okay, we've got to use the slope formula for 72 through 75. So just a reminder, the slope formula is y2 minus y1 over x2 minus x1. And these are written as subscripts because it's just saying the second y minus the first y. It's not y squared. So I won't label all of them, but I'll do this first one slowly, and then I'll go pretty quickly through the other three. But this is our first x and our first y. That makes them x1 and y1. This is our second x and our second y, making it x2 and y2. So we do y2, which is 5, minus y1, which is negative 6, over x2, which is negative 2, minus x1, which is positive 2. Please remember, minus and negative means plus. Just keep, change. Giving us 11. Negative 2 minus 2 is negative 4. Now, feel free to slow down and do that whole process of labeling if you want to. But for the rest of these, I'm just going to plug them in, and you can always pause and check my work if you want to. But we'll do y2 minus y1, 4 minus 4, over x2 minus x1. 4 minus 4 is 0. 6 minus negative 3 is the same as 6 plus 3, which is 9. This is important to remember. When 0 is on top, that means the answer is just 0. That's a flat horizontal line, slope of 0. However, let me go and skip to 75 so you see the difference. We do y2 minus y1 over x2 minus x1. 4 minus 1 is 3. Negative 3 plus 3 is 0. When you get 0 on the bottom, that means the slope is undefined, or you can say no slope. Either way is okay. And that means you have a vertical line. That's why they say the slope is undefined. So 0 on top, slope is 0. 0 on the bottom, there is no slope. It's undefined. Okay, back to 74, we do y2 minus y1 over x2 minus x1. 5 minus negative 6 is the same as 5 plus 6. Negative 1 minus 8 is negative 9. Okay, to be continued.